All right. So as I said, today will be a live session. It'll be a really short videos for the first part is talking about like 2D arrays and array, and then the second part we talk about linked list. It should be a two short video. The rest we'll do a Discord session which are longer, and we'll do a Q&A on the assignments. All right. So let's begin. So we talk about pointer on Thursday, right? And we basically said, hey, array is essentially can be replaced with pointer, quote unquote, in C, right? Because when you have an array, like a one-dimensional array, right? You get the beginning address of the first item, so you can do pointer arithmetic to move up and down that range that you allocate, right? But let's say, what if we want to represent a 2D array, which we need all the time, right? Things like machine learning, sometimes we need to do a matrix multiply, which multiply two-dimensional metrics so that you can keep training and doing the inference, basically doing useful stuff that we we mathematically define, right? So let's say I want to represent a 10 by 20 matrix. You can do that easily in C by just declaring something like this, int a1020, right? Alternatively, you can do something like this as well, right? This is basically making an array of pointer, right? This is what you see here is basically an array of pointer where you basically have an array, right? Each one of these are pointer. 3, 4, 5, 6, 7, 8, 9, right? So these are pointer that can point to another array, right? And when you use something like this, just you need to make sure to remember to malloc, right? To malloc for each of these pointer that point to the next dimensional of your array. You can also use this. This is probably a new thing for you. Basically, now is two layer of pointer, right? So basically now what you have is you have the variable a, which is a pointer to the pointer. This is pointer to a pointer, which is basically means that because pointer can be an array, this thing can point to one array after you malloc, right? You malloc, and the data type here is pointer. You have then a bunch of pointer inside, right? Which each item here you can basically point to the actual array itself, right? So if you talk about what are the differences between each of these data type, right? The static array, the topmost part, A1020, right? That's the int A1020. So that's a 2D static array. This can be visualized as if you have this giant box, right? Where, oops, all right, I'm not good with this pen. Sorry, let me fiddle around with this a little bit. Trying to get used to using the uh, Wacom board so I can draw things. And it's pretty fancy, so if I don't like push if I don't push the tip on the screen, it thinks I'm trying to like lightly brush things. So this is in A1020, right? You have two-dimensional matrices where you can go basically the dimension is 10 by 20, right? That's the dimension. And it's static means that it's the size is fixed. You cannot make it such a way that it's gonna get wider from 10 to 15 or from 10 to 25. You cannot make it higher from 20 to 30, right? It's going to be static 10 by 20 in terms of the dimension. And again, within DRAM, right? So let's say this is your DRAM. What would happen is that your first row, right? The first row, which is this part, is the beginning of your array. So let's say it's this box right here, right? So that's the first row. The second row would be put next to the first row right here. So because DRAM is one-dimensional, the way this works is when you have this two-dimensional matrix, they just put next to each other in a contiguous block, right? And please note that when you try to pass in and out matrices, like a 2D matrix, into a function call, or out of the function call, this is not really convenient because when you pass them in, they do this deep copy where we'll learn about the deep copy in a bit, right? On Thursday. But what actually happened is you create, basically the computer would create a different array and you copy the data over inside a function. It does something with that particular array. And when you're done, it's not getting returned. It's not getting returned back to your original matrices. So typically, you might want to play with, first of all, you can have array of pointer, which is something like this, right? As I said, this is looking it's going to look something like this, right? This is A. It has 10 boxes in them. And each one of these are pointer, which you can then malloc, right? So when you malloc, you get another array, right? Over here, you can malloc for any size. And when you want to allocate two-dimensional array, just keep going through this array A and malloc for every pointer, right? But then again, you have this dynamic array of pointer, which is actually, to be honest, for me, I think this is the most flexible because essentially you have this variable A, which you first can malloc, right? But because this is a pointer to the pointer, what should be the data type that I put here? Size of what? So what should be the size of here, right? So there are two possible options we have seen so far. This can be an integer or an integer pointer. Which one is correct? This is option 1. This is option 2. So what do you think? Should it be integer or integer pointer? What is the type of the items in the variable A? What does A point to? In start, thank you so much. Yes, because it's a pointer to pointer, right? So when you do a malloc, you want to allocate the data. It has to be the size that the pointer is pointing to. The type is in star, in star, right? So this is in star. Afterward, once you're doing this, you basically get this array of size 10. Each one of these items are pointer to integer, right? Is a pointer to integer, which then you can malloc afterwards. So this is malloc. Now over here, should that be size of int or size of int star? So I want 10 by 20, for example. I'll do malloc size of what? For the second level, should that be int or int star? Actually, this now is int, right? Because you have, so A point to int star. But when you go to the next level, right? When you look at star A point to what? Point to int, right? So in the second level, because now we are in the lowest level, it actually not point to a pointer. It points to just individual integer. But when you malloc, you get 20 of those. So after you do malloc size of int, right? What you are going to get is this array of 20 integer, right? These are int. For each of these item in the box is int, right? So now, is it more clear where I can use int star star to do a two-dimensional array? The first layer is just pointer to the pointer. The second layer is now pointer to integer. So the second level when you do malloc is malloc size of int. All right. So now we can play around this concept a little bit, right? And use this to pass around variable, but not one single variable. Now pass in a matrix or a vector. So we can pass 1D array as an input using pointer, right? So let's say you have int star p, right, which point to an array of integer. Now you can pass in p. You can pass in p. Now you can pass in the address, right, to your one-dimensional array. Why is that convenient? That's actually pretty convenient if the function that you're calling want to modify whatever is in that array, which means that you pass in the address, you do the modification, you don't have to pass anything out because the data is already modified afterward. We'll show this on the demo on Thursday. We'll show this on a demo on Thursday. So I'll keep the demo on Thursday's lecture because we have more bigger crowd. Basically, we should have the whole class. So it's more convenient to do all the demo and the coding on Thursday. Again, we'll do a quick review on this, but I'll make an announcement for students who did not attend to the lecture to quickly watch the video so that you have a brief overview of what's coming on at the beginning of Thursday, right? You can do that for a 2D array as well. So let's say you have star star p, right? What you can do is to pass the address to that 2D matrix into the function, right? Because now it's the first level is pointer to the pointer, which is an array of pointers. So we can pass the address of the first item of that array to the pointer. So you can use pointer to pass things around across different functions as long as you tie the size of the array, right? You want to make sure you know what's the size because otherwise, when you loop through the elements, you don't know where that pointer ends. So you pass in the pointer along with the size. For example, you can pass in array, one-dimensional array, something like this. I can do vector add, right, by passing in star A and star B, right? Over here, this is not entirely correct because, as I said, you also need the size, right? So if you want to add two things, A and B are one-dimensional array, and you want to do the pairwise adding, a safer things you might want to do is something like this: int star A, int star B, right? And then int size, right? And then you also want to have something to get the return value, right? Because it's adding to array, right? So afterward, the other thing that I would usually do is I have another array that I pass in that I use as an output in star output. So that way, you don't have to return anything. Once in the vector add function, I make sure that I take in the value of A and B, add them together, write the result to the output because I pass in pointer anyway, everything is modified already. So you have the correct output afterward. We will do a demo on vector addition on Thursday. All right. And you can use the same concept to pass in 2D arrays as well because by passing in the array of pointer. And again, over here, you just pass in size X and size Y. And don't forget to somehow take the output back, right? So one thing I can do is to not just passing in the input. So I pass in right int star star A as the first input, int star star B as a second input, int size dimensional X, right? Int size dimensional Y, and then also maybe int star star output. All right, so this is basically how I can manipulate uh, C pointer so that I can work with array and work with matrices, right? So again, we'll do a demo on Thursday. Uh, let's resume the lecture. And as I said, now we'll continue on to the topic of basic data structure in C, and in which case we will talk about one of the data structure that we use a lot called linked list, right? Um, so when we have the concept of a pointer, right? This is actually a concept that's useful to implement things that allow you to point to the next item, right? Things like a linked list or a tree. So if you're in a DSOP class, you might have learned about how the tree works and how to implement them in other languages. In C, you can also do that because you have a pointer that essentially applies to the concept of I want to point to the next item, right? So the general guideline is this. Basically, you would declare a struct that consists of the data node itself, whatever you want to store in terms of the data, then one additional pointer to point to the next item. Like most of the time, I would type def the struct so that you don't have to always declare using a struct node or struct node type or whatever. And then you make sure there's a pointer that points to the first item, such as a root in a tree or a linked list, and we'll play with these concepts going forward right now, as well as the lecture on Thursday. We can keep using malloc to append to new nodes so that you can have a structure that looks like a list, right? We also play with this throughout our exercise and assignments. So let's go to some basic concept of linked lists first, right? So what is a list? What is a list? Let me ask this question. What is a list? You've been to Python programming, right? So can someone tell me what's your understanding of a list versus what's the difference between a list and an array? So what are the key differences between a list and an array? All right, can someone tell me the difference between a list and an array? Array is fixed size. Yes, you're perfect. Basically, if you have an array, right, the size is fixed. And if you want to maintain an array of something bigger, you have to kind of resize them. There's like a process of resizing that thing. A list is by definition, right, from the English understanding, from just looking at the word list, right, it's a collection of items, right? So if you think about this is a collection of items where you can first of all iterate, right? You can go through your list and you can keep adding. You can add items and delete items from the list, right? Basically, you can manipulate the size of your list by adding new items in or get rid of something. So let's say I have a list of integer, right? List of integer. It can look something like this. A list of 1, 4, 7, 8, and that's not 4. 20, right? 100, 3, 5, right? So this can be my list, right? And I can add new items in, and I can delete things out. I can get rid of 20, right? So it becomes 1, 4, 7, 8, 100, 3, and 5. I can add new items. I can add 6 in here, right? Now it'll be 1, 4, 7, 8, 6, 100, 3, and 5. You can iterate through the list. You can go through the list. There'll be some ordering in a sense that when you iterate through the list, you will get some pattern out from this is the first item, followed by the next item, followed by the next item, right? Linked list is a way to represent a list where you have the first item. In this case, you have the first item, which is number 1, that links to the next item, which is number 4, which link to the next item, which is the number 7, which link to the next item, number 8, link to the next item, number 6, link to the next item, number 100, followed by number 3, followed by number 5, and number 5 will basically link to nothing, right? We call this the first item. And then it has this chain of numbers that it does link things together, right? My question is, how do we implement this in C? How do we implement this particular data structure in C? I have something that looks like a chain of number, right? And I can add items in, and I can take something out from this list as well, right? So the first thing you have to figure out is, what is the data you're storing? What is the type of data you are storing right now? You have the integer, right? So let me call this thing a node, right? Let me call this thing a node. A node should consist of, first of all, the data itself, right? The data itself, which in this case is your integer. And the second thing is it need to have the pointer to the next node, right? So now let's talk about this node and how to implement them, right? The node will consist of two things. First, the data. Second, pointer to my next node, right? How do I do that? How do I create a data type that consists of multiple types of things in here? What are the things we've learned so far? We've learned about this particular, yes, thank you, from the chat. You can create a new struct, right? So let me name it struct node, right? Node. I can say struct node int my data. So that'll be your actual data, like 1, 2, 3, 4, 8, or whatever you want to store, right? And then it has to point to the next item, which means that it has to be a pointer, right? So let me call this pointer next. What is the type of my pointer? The pointer point to what? It point to struct node, right? So I can do this. Struct node pointer next. That's my definition for the node. It has two items in the struct, right? First is my integer and my pointer that point to another struct node, right? Integer and pointer. We just create a new data type called struct node that can point to the next item. All right, so that's how you create the node. So let's say I have a node that looks like this. I have a linked list that looks like this, right? It has number 1, right? Point to the next node, which is, I guess, number 4. Point to the next node, which is number 7, right? And let's say I want to add a number, I don't know, number 3 right here. What if I want to create another node and add number 3 right here, right? One thing I can do is what? Well, first of all, I'll malloc for this new item, right? I create a new node. I store, so that's the first step. You malloc and you store 3 in this guy, right? Now let's go to the next step. The next step is fiddling with pointers. Step 3, fiddle with pointer. Let's say that that's location pointer A right here, pointer B right here, pointer C right here, and let's say that's node X. This is node X. This is node Y. This is node C. What do I do first? Right now you have pointer B, right? Right now you have B the pointer, right? Point to node C. You have pointer B points to node C. Your goal, right? Your goal, you want this. You want pointer B point to node A, and then point to node X, my bad. Point to node X. Pointer A point to node C, right? How do I do that? Three A, what do I do? 3A, what do I do? I make A point to what? Point to X. Wait, I make pointer A point to what? C, right? Not X. X is itself. Pointer A is like node number 3. So I need to make sure this pointer point to this guy, right? Yeah, it's okay. So I make A point to C. Pointer A point to node C. Then 3B, I do what? I make sure B, right? Point to node X. Pointer B, point to node X. All right. We will show you how this can be done in detail when we implement this, but the high level idea is essentially this, right? Essentially, what we want to do is to make sure we get rid of this link, make sure this link point here, make sure this link point here, and you're done. And you're done. All right. Now that's insertion. Going through your linked list is also pretty simple, right? So let's say this is my data. And let's say I call this next, right? Handwriting is too bad. Okay, next, N-E-X-T, right? This is my pointer name. So let's say I'm in node A. I want to go through my linked list, right? From node A to node B to node C. I can do something like this, loop. And let's say I have struct node temp, right? And let's say I have a pointer called first right here, right? So I do temp equal first. This means that temp point to A, point to A. If I want to measure temp now point to B, what do I do is temp will now equal, right? Temp next. So in C, note, right, note here. A, arrow, B, when you actually do like arrow, like type in, basically when I wanted to put the arrow sign here, I can type in this. Dash greater than, right? This is equivalent to A, ID reference A, and then dot B for a struct. Because the pointer is a pointer type in struct, right? So I can do temp equal star temp dot next. This is the same as temp equal star temp and then close parenthesis dot next. So that I point to the next item. I can use the arrow sign. It's the same thing. C would convert the two operation, which is basically now the exact same operation. After I do this, temp now point to B. So I can keep looping this until I'm done, which means that loop until temp next equals null. Because at the end of the day, this thing would point to null or nothing. Right? So that tells me the end of my linked list. So that's how I can go through the linked list. To delete your linked list is also something pretty simple. So let's say you have the linked list that looks like this, right? 1 point to number 4, number 4 point to number 8, which we just inserted, and number 8 point to number 7, this point to null. If I want to say get rid of 1, not 1. If I want to say get rid of node number 4, right? What do I do here? Ideally, what we want to do is to make sure that the arrow, right, the arrow here point from here directly to here, and you're done. The problem is you need to make sure you don't forget to free this node. So the first step is to free this node. The second step is to make sure the node 1 point to the node 8. The problem is if we do this right away, if you free the node 4 right away, if you free the node 4 right away in the beginning, you don't have that link anymore. You don't have that link anymore. So step 0, right? Step 0 is to make sure you save that link. Save the link to 8. And because life is actually simpler than this, you can reorder this a little bit and finish the deletion into quick step by first freeing the node. First, make sure that node 1 dot next, right? Node 1 next equal to node 4 next. Basically, this means that node 1 next, which is this guy, point to the same location as this. Right? So that's the first step. The second step is then free node 4. And then you're done. Make sure you do the pointing first and then free the node you want to delete, and then you're done. Because you just get rid of that item from your linked list and you get rid of the memory leak problem by freeing the node you just deleted. And that's it. As I said, we will do a demo on Thursday quickly on vector add, matrix add, and do a full-blown linked list example, which we'll have a code as a sample code posted after we do that a demo on this coming Thursday. Right now, I want to dedicate the time for any question and answer related to your previous in class, your assignments, any error message you saw on VS Code. Yes, that's a great question on the chat. Is it correct to think of struct as a class in OOP? That's great. So let me go to, I guess, blank slide, right? Is struct the same as class? So for those of you who take out of object-oriented programming, right? What are the properties of a class? What are the properties of a class? So first of all, you can have a collection of data. Can have of data in there, right? You can have function in the class, right? You can have things like inheritance. You can have also things like abstract class, right? So these are some of the properties of like a quote unquote class, the concept of a class in object-oriented programming. What about a struct? This is a collection of items, right? And I guess I can probably have a function, right? Have function pointer. But it's not as convenient as a class in a sense that you cannot have like another class or another struct that inherit from a different struct. You cannot use the way to like provide an abstract version of the struct so that you can implement them later. So in C, a struct in C is a more not more actually, it's less flexible. So if you need a class, if you need a real class in C, what's that? Anyone heard about this new, not new, it's actually a pretty, really old language that give you a class? Use C++. So C++ is actually really, really powerful and really, really fast because it gets the benefit. It gets a lot of benefit that C provide, but give you object-oriented programming. You can now have a class, and to be honest, once I learned how to use C++, it's actually really, really convenient to program in them. A lot of modern day back end, like modern day application that support a lot of back end usage backed by C++ or C. So it's actually pretty handy to learn how to use them, right? So again, that's a great question. Again, now if you do a Q&A, right? Things like error message, seg fault, or anything that you run into. I'll quickly stop the recording because I promise this is going to be a short video focusing on your assignments and anything you try to do and sometimes fail, sometimes succeeded in so far.